All right, this is synthetic division. This is the note sheet from last week that we did on polynomial division, right? We started with monomial division, and then we moved on to binomial division, but we did long division, and today we're doing synthetic division. So this is the same note sheet, and we're going to do it on synthetic division. So there was a empty box that we haven't filled in. All right. So basically, this is a second technique, and you are welcome to always use this technique when it is a linear binomial. So binomial means there's two terms, and linear means that the highest exponent is 1. So in other words, you don't see an exponent because it's the invisible 1. So this technique, what I'm about to show you, does not work on x squared plus blah, blah, blah. Okay? That doesn't mean there isn't a technique related to it, but it's just as complicated as doing regular long division, so may as well just do regular long division. But today we're doing synthetic division with this. Now, how does that work? Okay, so first thing we're going to do is we're going to take this x plus 4, set it equal to 0, and solve. And many of you can do this in your head, which is great. All right, so I subtract 4, I get x equals -4. All right, and what we're going to do, what are we going to do with this is we're going to write it over here, -4, and put it in a little box. So we put the -4 in a little box. All right, and this is the problem we're doing example 2a. Now I'm going to copy this, but I'm only going to copy the coefficients. First, I want to make sure I'm not missing any terms. Remember, we want the exponents to go down nicely. So this is 3, x cubed, x squared, x to the first, no x. So 3, 2, 1, none. So that's good. Nothing skipped. All right, but now all I'm going to do is write the coefficients. So that 7x cubed gives me 7. The 29x squared gives me the 29. The 9x gives me the 9. And then there's the 20. All right, so that is almost set up. Now, I'm going to draw a line so there's enough space for me to write numbers above it, between that and the line. So I'm going to draw a line there. And I'm also going to draw a line here. Okay, so this is like on the left side of this 20. It's between 9 and 20. It's about, and if you want to draw it all the way up, that's fine. But I like to draw it here. Okay, now, so that's the setup for synthetic division. Notice there's not a whole lot of writing. Okay, now, and this is how the synthetic division works. So the first number comes straight down. And then you're going to do -4 times 7 is -28. And you're going to write the product here. And then you're going to add. 29 plus -28 is +1. And then you're going to take that -4 and multiply with the 1. So that's -4. 9 plus -4 is 5. And then you're going to take -4 times 5 is -20. And 20 plus -20 is 0. So that's it. Okay? Now, what's the answer? Okay, so remember this original problem started with an exponent of 3. And what's going to do, it's going to go down by 1. We just divided by x. So it's like x cubed divided by x. The exponent is going to go down by 1. So you're going to write the 7 as 7x squared. Remember I just said the exponent is going down by 1. So the 3 went to 2. And then from there, it's going to go down by 1 each time. So it's plus 1x, or just plus x, plus 5, no x. And this here, the little cubby hole here, that's the remainder. So this one has no remainder. So this is my answer. All right, that is it. Let's do 2 more examples. Is there 2 more examples? Yeah, there's 2 more examples. All right, here we go. So this is this flip side. It's the other side of that paper, or it's just the second page, okay? So in this one, though, there is a term missing. What I mean by that, so it goes from x to the 5th, then it goes x cubed, x2, x to the first, no x, okay, or x to the 0. So it's missing the x to the 4 term. So when I write this out, I'm going to put a 0 in this place. And I'll show you that one in a second. So x minus 7 gives me a 7 to put in my box, okay? And then the coefficient of x to the 5th is 1, and I'm missing the x to the 4 term. So I'm going to put a 0 for that missing term. And you definitely need it for synthetic division. And then -39 is the next one. Then -70, 5, and negative 41. All right, so I've copied all my coefficients. All right, then I draw my line. Draw my little line here. That's my little cubby hole. Now, so the 1 comes down. Then I do 7 times 1 is 7. Addition, 0 plus 7 is 7. 7 times 7 is 49, and it goes there. Negative 39 plus 49 is 10. Then I do 7 times 10 is 70. Negative 70 plus 70 is 0. 7 times 0 is 0. 5 plus 0 is 5. 7 times 5 is 35. And then when I combine the last set, it's negative 6. So this time I have a remainder of negative 6. Okay, and remember the original problem was x to the 5th. So this means this is going to start at x to the 4th. So it's 1x to the 4th, but I don't bother to write the 4. Positive, so it's plus 7x cubed plus 10x squared. I can write the 0x, but I'm not going to, right? I'm going to skip the 0x and just go straight to 5. So it's plus 5. Plus, the remainder is negative 6 over the divisor of x minus 7. And yes, you are welcome to write, instead of a plus a negative 6, you can write just a minus 6 over x minus 7. All right? That's the second example. Let's look at the third example. All right, so in this one, the difference between this problem and the last problem is that I have a leading coefficient on my divisor. I have a coefficient of 4. Okay, that's going to change things. All right, so this one also has a missing term. I am missing the x squared term. So that's two different things, two new things. Well, that's not new. That happened last time, right? But this is the new thing. This is actually a very common mistake. People forget. Well, I'll get to that in a second. All right, so go ahead and set that equal to 0 and solve. So 4x plus 2 equal to 0. Solve that. So that's going to be minus 2, 4x equals negative 2. Divide by 4. And I get x equals negative 1/2. Make sure to reduce your fractions. It's not that it's particularly important, but it makes your life easier when you reduce your fractions. All right. Now, so let's write this out. So negative 1/2 goes in my box. Write down the coefficients. It's 12, 6. I am missing the x squared term, so I'm going to put a 0 there, and then the 12, and then the 6. All right. Draw my line. Then bring down the 12. Now, negative 1/2 times 12 is negative 6. Make sure you know how to do multiplication by a fraction. If you don't, please ask me. 6 plus negative 6 is 0. Negative 1/2 times 0 is 0. Add the 0. Negative 1/2 times 0 is 0. Add 12 and 0, and I get 12. Oops, I forgot my little line. Negative 1/2 times 12 is negative 6. There, no remainder. All right. Now, what do I do with this? So, remember, the exponent was x to the 4th to begin with, so this is going to be x cubed. So it's 12x cubed plus 0x squared plus 0x plus 12. Well, here's the bad news. That's actually not the right answer. Okay, I forgot already. Okay, so what did I forget? Well, I need to divide all these terms by that leading coefficient. So this is the extra step when you have a leading coefficient or divisor. You're going to take your final answer here, divide by that number. Divide by 4 in our example here. So I'm going to divide each term by 4, and I get 3x cubed plus 3. Now here's the weird part. Whatever is in here, if you have a remainder, you do not divide by that. Okay? Because remember, when we had a remainder, we put it over our divisor. So you're already dividing by whatever you're supposed to divide by. So when I have a remainder, I'm going to put plus whatever it is over the 4x plus 2. So that's why you don't divide the remainder, because you are already dividing it. Okay? So here is my final answer for example C. Okay? That's it. Have a good night.